Test, 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 test. Test. Test, 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 test. Alright. Alright. Let's get this done. So what's the goals for today? Well, I really want to practice my DP today. I haven't done a DP problem in about like 2 weeks probably. 2-3 weeks. I don't know. And I want to get my DP game up. So we're gonna solve the daily real quick. Hopefully real quick. If not, we're gonna struggle on the daily. But eventually we'll do some DP problems today. We'll probably just do leak code DPs because those are probably gonna be the easiest to learn off of. But besides that, that's the main goal today, is to learn some DP. Maybe I should change the stream title to Learning DP. I don't know. We'll see. But let's get this daily done. So the question is, count subarrays with fixed bounds. This is like the 8th sliding window-esque question this month in a row. But it's the last day. I'm about to get my March badge. By the way, if anyone's curious, I practice every single day. I just don't live stream every single practice. So if you look at the thing that says day 4, it just really means episode 4. So if anyone actually is concerned, or they're like, you're not grinding hard enough to make the team, trust me, bro. Just trust the process. But besides that, though no one has said that, I just want to put that message out there. Let's get this question done. A friend of mine says I can't do this, but he a hater for real. So we're gonna get this done. So darken this paint up, hit with the marker, and we're good to go. Alright. So the question is, you can only count a subarray. Just count the subarrays that have the absolute min and the absolute max that we want, right? So in this case, the min is 1 and the max is 5. So that's the case here. We do have a 7, but we're not allowed to include the 7. So what can we do about that? The obvious answer, the stupid answer, would be to brute force this by double looping it, but that doesn't work here because the bounds are 10 to the power of 5. 10 to the power of 5 squared is like 10 to the 10. That does not get processed in a second. So we can't do that, so we're probably gonna have to be redoing an O of N solution, which is what leads me to sliding window. I don't know if it's exactly a sliding window, but it's telling me that. So we're gonna start off with a pointer here. Oh, when I move these pointers, because there's a black background, it's gonna get mad at me. Whatever. And a right. So obviously we only have our min. We're gonna have like a set. So we don't have our min, so we're gonna move our right pointer forward. Okay, well, this isn't our max, so that's fine. So keep moving. Now that we find our max, we can see that this is a valid subarray. Now since this is a valid subarray, we can keep going forward. Is this less than our max? Yes, it is. So we can keep going. Now this is a valid subarray. But if we go one more time forward, we see that this isn't a valid subarray because this 7 is here. So we can't like technically include this. So we could technically move this pointer all the way over here and then restart this check from here. But the problem is that we kind of know that this isn't going to be valid, because for it to be a valid subarray is you must include a this and a that, right? So we obviously know that this isn't going to work, and yeah. So my initial thought here to speed up this algorithm, just by thoughts, is we can count all the positions where we can count where, like, stored in a map. So we have the 1. So the 1 location would be here at index 0. Here our 5s would be at index 2 and 5. Right? 0, 1, 2, 3, 4, 5. So we see that here's our bounds, right? And these are going to be sorted. They're just guaranteed to be sorted, I'm pretty sure. And we're gonna start by doing this. We're gonna pick which one of these are min. As long as they're both exist, we're gonna pick the min of this and set that to our left, which is like this 0. So right now our left's gonna be here, and then our right's gonna be here. Now in between this, now we have our left and our right. We're gonna check the max . We're gonna check the max of this like inner part. And if the max is less than, like, if the max is less than our what's it called? I don't know. If the max is less than this right part, we know that this is valid, and we can move the right pointer forward and keep doing that check. But the problem is, every time you do that check, like the max, if you call the max function in Python, that's an O of n operation. So technically, if we did this algorithm and we just kept moving this right pointer forward and we checked max, this would be O of n, O of n, O of n. In worst case, that would be O of n squared. If anyone wonders why that's the case, is because if you have, say 1 is here, and then 5 is here, and you have 4, 3, 2, blah, 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 right? Just assume that these are less than 5, right? So if we run the max here, every time we expand this subarray, we need to check. So like if our pointer is here, every time we expand this subarray, because worst case, this can be, 5 can be like right here, right? Every time we expand this subarray by moving this right pointer forward, we have to make sure that this max is like staying there. Well, we're gonna run, if we run the max function, this is gonna recount all this, like in up to like where our pointer is. So like it'd be like O of whatever the right pointer is, like wherever that is, right? Which eventually will lead up to O of n squared. However, we can say that we can go, it'd be like, okay, well, we can just check our right pointer. Is the right pointer less than our max? Well, that shortens it, but we still have to do this computation here, which is like this middle part, let's say this middle ground. So if we had 1 to 5, say this is like 0 and n minus 1, right? We're gonna be running this max function, which is gonna have to check all of this, which isn't that big of a deal. But I think I have a better way of doing this. I could make another array where in this array, what color do I pick? I don't know if this is necessary, but it's an idea, just in case. Well, I can have another array called the max array. And now in here, I can store the max. So 1, the current max at this index is 1. Well, the current max at this index is now 3. The current max at this index is 5, and then 5, and then we hit 7, and then after that, it keeps going. But this doesn't really work because this is not gonna account for if we want to like chop this off, it's not gonna account for that. So this idea is not gonna really work now that I think about it and I draw it out. Because everything to the right, the max of this would be 7, so we're gonna kind of have to do this idea. And if we only run this max one time, it shouldn't be that big of a deal towards our runtime. Yeah, I do have an account in Code Forces. So, let's go here. And let's get rid of that stupid ass idea that I thought of. And let's go back to this map idea. So let's just count up our min and our max. So again, 1 is tied to 0. And 5 is tied to 2 and 5. Right? This is what our map looks like. And we'll just pick, the left will be, we'll kind of like iterate it like this. So we'll just pick like that and pick them, and the left will be the min of these two and the right will be the max of these two. Right? And then from there, we can go and set these bounds. So this pointer, the min is 0, so left is going to go right here. This is 2, so the right's going to go right here. Now we take the max of this subsection, and then we compare it to this, or whatever our, we don't compare it to that, we compare it to our, we take this, and then compare it to the absolute max. Right? If this passes, then we know that this can be a valid subarray. Now, since this initial setup is valid, we can go and we can say, okay, well, let's now go and increment this pointer, and then from there, every time you increment this pointer, we can just check this. And if this is right, we can append to our answer, and then we keep doing that until we hit an invalid spot. If this is invalid, then we know it's not going to work, and we have to move on to the next step. Which the next step would be running these. The next step would be running these pointers again, right? Because even if we go, okay, well, if we want to rerun the left pointer, we know none of this is going to be valid because this is staying here. But this is also assuming that everything left of this is also not minimum or the max. This is like only assuming for one case, so this kind of solution isn't really working in my head right now. So there has to be a better way. Because I just realized that this works only for this case. Because we're going to be skipping. Because technically, this is valid as a whole subarray because the min is here and the max is here, nothing exceeds that. So it's not really the start has to be the min and the max has to be the max has to be the 5. So the solution isn't going to work right off the gate. So we got to think of a different solution. I feel like I'm cooking with the map idea of storing where these elements are. How's it going? Let me think. I mean, could I just literally just send the sliding window? That is my question. Yeah, that's true, but like I use LeetCode just to warm up and for fun, so. And also I'm still not that good to the point where every LeetCode's easy. So I still do learn stuff from LeetCode, some LeetCode problems, but yeah, I don't strictly grind LeetCode. Okay, so if I just full send the sliding window approach, and we have like a set, which just keeps track, or I could like have like a min and a max for each like kind of pointer. We'll go here. The max and the min is 3 and 3. So since that's sick, that's sick. I've been grinding LeetCode for like 2 months straight. It's actually kind of crazy. I love doing the dailies though. The dailies are fun. Besides when they give this, like, they're not fun when you do the same, when they do the same type of question 8 days in a row, but I like doing the dailies. And they're also like, I like doing them because like they can be quick sometimes and just pop out a quick problem. Alright. I'm definitely better than what I was a couple months, because I really started like, I want to say, I didn't start grinding like competitive programming like until like seriously grinding until like a week ago, like 2. But I have been doing LeetCode for the last 2 months, for like, it's been 55 days with my streak. And I have noticed a lot of improvement. I've looked back at solutions I've done in the past, and like it's like actually kind of mind blowing. But the short term improvement is not a lot. I can actually show you an example of like improvement. I mean, to be fair, it's not the most fair comparison, but it is one. It's trapping rainwater problem. So that, if you don't want the solution, don't look. My bad. I forgot to like tell you that, but don't look if you want the solution. But I'm gonna go it out. But like year ago, like almost like basically a year ago, I just full sent. This is what it was. Like, this is trash. To be fair, a year ago I really didn't know what I was doing, and I haven't been, trying for a year, but this is trash. And then I come in today and I solve this problem in like 10 minutes with a clean solution. It wasn't 10 minutes, like 15 probably. I don't know. Actually, let's see. Can I see? It doesn't tell me. But whatever. I like 15, 20 minutes. Clean ass solution too. So there is progress, and it's nice to look at it, but sometimes it does get demotivating when you're getting cooked consistently and you're not seeing improvement because you're only looking in the short term. But if you can accept the fact that it's a long game, you'll be chilling. But every day you show up and you solve a problem, you're 1 inch better. That's all that matters. Alright, what was I waffling about? Oh yeah, this problem. So let me just try the original sliding window way. Like 800, bro. I'm ass. I've only done 1 contest live because I've been doing school, so like, and all the contests are in the morning, so I can't really do them. I was only able to do 1. And my first contest was a div 2, so I got kind of smoked. Alright. That's fair. Alright, let's try this original sliding window approach real quick. So, the absolute min and max here is 3 and 3 of the subarray. Now, yeah, the min is out of bounds, but the max is here. See, I don't know though. Because what is the condition that I move my right pointer? Alright, I'll see you, bro. Have a good sleep. Because, see, with this sliding window approach, it's like you have to figure out why you're moving left and right. And here, when would I move right? Because if I had the minimum, oh, I would move, see, but let's just walk through this algorithm and keep going. So whatever. I'm just gonna assume that you're gonna move left when the max is greater. So here, this gets set to 2 and 3. So that's still fine. This gets set to 1, which is valid. So this is still 1 and 3. And now we have 1 and 5. Okay, I'm setting myself up for a an n squared solution. That's not gonna work. I don't even think. Watch out, guys. Alright, I'm gonna lock in real quick, try to get this problem. I'm not gonna read chat for like 10 minutes. See if I can really get this problem. I gotta activate my thinking. So I really like my hash map idea at the start. Whoa, I am not writing that array down correctly. 135, 275. 1, 5. So let's do the map idea where we go here and we have, well, our absolute min is at 0 and that's it. And our absolute max is at it is at 2 and 5. So I like this idea of where we can kind of like point to where we need to go at the start. So we kind of take this, we compare these two, and then we pick the absolute. We set our left equal to that min, and we set our right equal to that highest part. The problem is when you do this solution, you can kind of skip over elements, right? Because if I had this 2, 1, 5, like this is a valid subarray. Or well, let me put the 3, 5 actually, so it makes more sense. Like the map would look like this. It would be, the min would be at 1 and the max would be at 3, right? So yeah, this is, but then we could check the middle. This is technically valid. But we also have to go look over to, but we're also gonna go and miss this element. Because we're only checking like this consideration. So, how are we gonna account for that? We can't just run max and min on everything because eventually you're gonna get O of n. You're gonna get n squared. You can't just be like, okay, well, let's take the min and max of this and take the min and max of this and see how far we can go. And that also doesn't tell you where this subarray ends. Which is the problem. So how can we account for that? Well, I'm thinking maybe no, I have not solved this one before. This is new. I just solved a lot of similar problems to this, I think. I just said I wasn't going to read chat, but I'm reading chat anyways. I don't care. I'm a savage. Who cares? What I'm thinking is maybe we can have a max and a min array. So for like example, let's say 2, 1, 3, 5, 7, right? Well, the min array would look like, okay, what's the min of this spot? 2. What's the min of this spot? 1, 1, 1, 1. The max array would look like this. 2, 2, 3, 5, 7. So if we pick a spot, let's say we pick this and this, we can go and look to the left and kind of see, it's almost like kind of like a prefix sum. You can kind of look right here, and then you can like, you'll be right here in this position, right? We'll be here, here, and then for this one we'll be at here and here. So for this one we can look at like the min and the max, so we can see that the min is not less than this point for all these elements, and the max for this point is not greater than here. And then again we can do that here, but we see that for this case this breaks, so we wouldn't include this part, but we would go and include this part. This solution works, but I need to prove it more, because now I need to take into account how are we going to get like subsections of it. For example, say I had this array, 7. Let's just take this same exact array, 1, 3, 5, and then let's say 4, and then 7, right? So we have this array. Well, the mins are going to look like this. 7, 2, 1, 1, 1, and then 1 for the rest of the array. The maxes are going to look like this. 7, 7, 7, just 7 for the whole thing, right? The problem is we obviously know that this is going to work. But if we look to the left, we're only going to be seeing these values, where there's no actual way to go and look and see, okay, well, when does this max occur? Because like if we let me draw this better. If we're like here and here, right, with the solution before, we just look, which we would be here and here in the array. I know I didn't draw it too well, but you get the point. We can see that if we look to the left here, that this whole subarray is valid, and then we can see right here that this whole subarray isn't valid because it's greater than our max. But the problem is that isn't true because we're not looking, there's no way to like split these up. Alright? So this solution doesn't work. But this would fix the runtime issue, because this would be basically, we could get an O of n solution out of this. So we need to find a way such that we can check the min and the max to the left of these pointers and actually find a spot where it doesn't like break. Which is, what is a way to do that solution? So I'm thinking maybe, let's do like a simple example again. Let's pull up the original question. 1, 3, 5, 2, 7, 5. So we can have an array. So again, our map, which stores our spots where these occur, which so here would be 0, and then here would be 0, 1, 2, and 5, right? So we have this map, right, which tells us where we can kind of start off at. But we also have an array, which this would be the less than. So we would have an array of indexes which store what is less than, like where in this like array do we have less than our minimum. So here we would have nothing, right? Because nothing in this array is less than 1. So we can also store where they're the largest. Well, ln, right? I don't know why. I should have said whatever. So we can also go and we can say, okay, something larger than this occurs at 4. So since we see that we can kind of take this left and right approach now, so we can take the min of this, the min of these two, where you start off at these pointers. So this is your left, and this is your right, just 2. Now we can check, okay, so when does this condition break? Well, this condition breaks at 4. Well, it's 2 less than 4, yeah. So technically this right pointer can go up to like just before 4, so like 3. And it'll still be valid. Again, with this left pointer we can see, okay, this never breaks, so we can just keep this as far left as we can go. Which then would give us a subarray of 0 to 3. Which would give us this, which is valid. And then from there, once we have that, we can go and then move these points forward, and you see that we run out of lefts, or like less thans, and we run out, and then they're not even anymore, so it's like impossible to keep going. Because if we try to keep going and we have this minimum 0, we see that this condition breaks if we set this to 5, because if you look to the left, something's greater at 4, so since they cross, you're not going to be able to continue. So I think this could work if I clean this solution up. So let me try this example again. So our map's gonna look like this. Okay. Technically this does need to be a map, but it's fine. Actually, these can just be arrays. It's fine. So the answer to this question would be this and also this. So it'd be 2. Now with our algorithm, would this work? So we can store the min, absolute min, which it doesn't exist, so this would be that, and then we can store where the maxes occur. So 0 and 1, 2, 3, 4, 5, 6, and that's 6. So we are initially set up with this. So left is 2, and right is 4. Now we can try to maximize the left side. So this is like the original subarray. We can see that if we take 2, which is our left, because we know this is our min. I don't know if this is gonna work actually now I think about it. This is too convoluted. Is there any way I can simplify this? Problem is, if you use the min and max counter as you go through, you're not gonna. There's no like set way to know when you should increment left. You do a dynamic sliding window. Why should this not even be a sliding window problem? Nah, it definitely is. Maybe I could do something like this. Maybe let me switch this up. Actually, keep the idea of like storing where these should start. So again, obviously we're gonna start here, and we're gonna start here. But then we need to figure out what's in the middle though to make sure that this doesn't happen. Well, again, if we keep the absolute min maxes in another array, we could do that. Or if we just set max between these bounds, that would work too. But whatever, let's just keep going. Let's just assume that this happens, which is probably not a good thing to do, but let's just assume that this is valid. So we can check behind ourselves. Well, is this less than our max or is it greater than our thing? No, it's not. So we can like decrement this left corner. We can kind of go and be like, okay, well, let's move this left corner here because it can go there. Then we look to our right. Is this greater than or less than our min or whatever? You know what I was trying to say. No, it's not. So we can expand this. Now we look again. We see that this doesn't work, so we can't move it. We try to go again. We know that this doesn't work, so we can't move it. So then we get this big subsection right here, right? Which works. So then if you take this and then you can count like, and then every time we move a pointer, that's a new answer, right? So then every time we move a pointer, so initially if this is valid, that's one answer, right? So that's +1. If you move right, that's another +1. If you move left, that's another +1, right? Because you have, the subarrays you have for this is 1, 3, 5. You have 1, 3, 5, 4, and then you have 2, 1, 3, 5, and then you have 2, 1, 3, 5, 4. So it's actually 4. So I need to add this correctly. We start off initially, that's right. If we move right or left, we can add 1. So we can look right, we can see that we can add 1, so that's add 1. Because this is already included, we move left, we can add 1. But since they both moved, that's considered a new subarray, right? Because you start off with 1, right? We start off here and here. So this is +1. Now if we go and we look left, we see that we can move, so that's +1, right? Because this includes the 2, 1, 3, 5, and then the 1, 3, 5. Oops. And then after that, we can check this way. And then we can see we move right 1, which is another +1, which calculates the 1, 3, 5, 4, because this is included. I'm tripping. I think this works. But is this going to be slow? Is my question, which I think it will be. So let's run this. Let me run this one more time. This is a 3. We start here, we start here. This is 1. Now we see that we can move this way, which is another 1. And then we can see, oh, let's just say that there's this 2 right here. My bad. And then we can see that we can move this way, which is a 1. But that doesn't work because we're gonna have to do another calculation because it's not adjusting for. Because what's happening is when you add like this, it's only taking into account. I mean, I guess we can add by this, and then we can add by how much of this changed, and like that would give us the correct response. So we could take like the original position of left, like minus the new, add that, and then new left, and then we can say the old position of right. We can say the new position of right minus the old position of right, and that will also give us that, and then we can just add this up, which would give us our answer. That would work, but I have a feeling that this is gonna be slow. I have just a sneaky suspicion that's gonna be slow, and I really don't want to implement this solution not fully confident into it. So, let me go and let's think about this. We have 1, 1, 1, 1, 1, right? You have a max and a min of 1. Now the problem is that in this array, in our map right here, we're gonna have that 1 goes to 0. It's gonna be this whole thing. And we also, well, that's also all we need, right? But the problem is, since they don't differ at all, that original idea of having left and right be assigned doesn't even work in general. So this whole solution is trash. It's trash. I just wasted my time. I just wasted my time. So I think I'm overcomplicating this by a lot. Alright, watch out, everyone. Ooh, that's not the right color. What happened to my color? Where'd my color go? Oh no, I used black. I'm dumb. Alright. New solution. Let's do this one. I don't know. I don't know if this is gonna work, but we're gonna try it. Okay, so let's just do a default sliding window here. If this doesn't work, I'm gonna go look at the tags and see if that can help me figure this out, because I'm gonna, and then some hints, because I'm gonna be lost after this. We start here and we start here. Well, is this greater than our max? And we're gonna assume the max is 5 and the min is 1. Well, is this greater than our max? No. Is it less than our min? No. So let's go and move this pointer forward. Again, same situation. No, it's not. It's right, because this is equal to our min. It's not less than our min, and it's obviously not going to be greater than our max. So we can move this pointer forward. And again, this doesn't count yet though, because we only have the min now in our set. Now we can look here. This is still valid, so we can move this pointer forward. Now that we see we've hit this, this, so we can keep like a window. Inside our window, we can keep like a map, which is the count of how much this occurs. So if this like map, if this like sum, if these both are greater than 1, right? Then we know that these are greater than or equal to 1. We know that this is a valid subset. So now we can start adding answers to this. So we know that this is valid, so we can say +1 here. Now again, we can now keep moving our pointer forward, because the rule says if it's greater than our max or less than our min, move the pointer forward. So let's do that. Let's cross this out. Go right here. That's valid still, right? So we can go and we can say +1. I'm already going to be missing an answer though, that I see right off the bat, because if I just do this +1, we're going to be missing this valid subarray, which can be fixed with a summation, which I'll address that. So this is kind of valid too, so we can say +1, that's 2. Now here, this doesn't work, right? So now, since this doesn't work, we need to go and move this pointer forward. So we're not going to include increase our answer or anything. we can go here and then we can say, like, our window is going to be still here, right? Because this is invalid, right? Well, here now this counts, so that's another +1. Then we can go here, and then now that we exit out of this one, the string map doesn't work. We see that no matter what we do, this won't be valid. And then we can kind of just skip over to this. Because we'll see that this right is greater than our max. Eventually that'll increment to the same. If the same, increment them together. And keep going. And the amount of valid subarrays. But this doesn't work. Or does it? Actually, it does. It does. This is working so far in my head. Because we accounted for 4, 1, 3, 5. We've accounted for 4, 1, 3, 5, 2. And we've accounted for 1, 3, 5, 2. Because we moved the left pointer forward. Now, problem is, what's the problem here? See, there is a solution where I could for loop, but that's definitely going to be out of time. Is there any, so this works for like a case like this, but my next problem is dealing with if like we have to run through every single numbers like this. If I can solve this case, we're gonna go. Else, we're gonna, I don't think of something different. So here, well, that doesn't work. Wait, I need to go and look at the runtime of another problem. Is this the problem? What is the problem that I'm thinking of? It's not this. This is not the problem. That's not the problem. What's the problem? Oh, we already said this. This is 10 to the power 5, right? Yeah. This is 10 to the power 5. Maybe. Maybe this solution does work. So what I'm thinking is, because the problem is, yeah, I can go here and do this same algorithm, but the problem is I ran into this problem before when I do sliding window. If I have this left and right, the left and the right are going to eventually go here, and then we're going to start incrementing like this, right? But the problem is I'm missing these individual pieces, right? Because they can be individual. A way I could get around that is I could say if min and max equal each other, count. If min and max equal each other, there's no possible way you could have like, oh no, that doesn't work either because left and right. So that's not gonna work because at the initial step, okay. And the way I saw I saw this, I used a for loop combo with a while loop. But I'm really scared that this is gonna go out of time. Whatever, I guess let's just full send that. I'm just gonna full send this solution. Let's get something on the board. I'm kind of lost. I don't really know. This is probably not gonna work, and this is not a good idea, but who cares? So we're gonna get the length of nums. And then we're gonna set for left in range of I, while we're gonna say R is equal to left, while R is less than N. We're gonna do this. I already know this is not gonna work, but Let's try something. Now, what did our solution state? We can have a freak map which can hold our frequencies. So, and this is going to be equal to max and k and max. Right. So this is our frequency map. And then we also need an answer. Then, obviously, at the end, return answer. Now, I'm gonna say freak. If, I don't know if that's kind of stupid. I'm just gonna say this. If freak at nums at r, this is gonna give me an error actually, if I say this. If q, now we're gonna check. If at k is greater than 0 and then we can say answer plus equals 1. Now we're gonna say, okay, well my if statements are all messed up right now. And nums at r is less than or is greater than r or equal to min at k, and nums at r is less than or equal to max at k. So basically what's going to happen is we're going to go through every single thing, set r equal to whatever left is, set this frequency map while r is less than n, and this number we're trying to add is less than or equal to the min at max, or greater than or equal to the min at max, and is less than the min at max. You can say, we're going to check if we're going to max this. If this is the case, you can then increment r. This is probably not going to work, and it actually did work, but actually, that does work. That explains a lot because this is going through every single thing. I knew that was going to work. I'm very confident in myself, and I'm the best, basically. But the problem is I'm telling you, this is going to TLE. That is what I'm confident in. See, I knew that was going to work the whole time because I'm a genius. I'm part genius, but, you know, it's okay. So I guess let's just spam a bunch of ones. I don't even know how many ones that is. And let's just see what happens. I think that's enough. Okay. Pretty slow, but let's spam more ones. Okay. Slow, it's going slow. Oh yeah, this is definitely gonna, it's approaching it. This is gonna be pushing it, I'm not even gonna lie. That's more ones. This is gonna TLE. Yeah, no. You can already tell, bro. You can already tell this is about a TLE. Like, bad. I don't even think there's a point in submitting this. Actually, let's send the submit and let's see if we can get away with it. You know, that's not like the best idea. Let's just see if we can get away with it. Yeah, we're not gonna get away with it. We're gonna TLE. Yeah. TLE's time limit exceeded. Okay, so again, I kind of knew that was gonna happen based off the bounds, but how are we gonna speed this up is the question. While also considering these numbers in between. Well, let me switch this up. While r is less than n, like this. And let's go here and let's set this frequency map here actually. Okay. So this is guaranteed to be O(n). Now, while this is happening, and this is happening, and this, we can just go in here and be like, okay, add up, add up, add up. However, if this condition breaks, we can now activate the left. So let me go up here and say left is equal to r, which is equal to this. So now what we can say is, while left is less than right, and because this breaks when the r breaks out, right? So that's like the case if, say we had like this, right? So left is here and r is here. So we're gonna go through this and we're just gonna get all the other little tiny subarrays throughout it. So while left is less than r and the frequency at mk is greater than or greater than 0, and the frequency at max k is greater than 0, what we can say is answer plus equals 1, left plus equals 1, and then what we can do is if L in frequency map at L minus equals 1. So what this is going to do is it's going to go through and grab all the smaller subarrays and just like count for us. Now after this happens, what we can say is r plus equals 1 and left is equal to r. We can kind of restart this process because we don't want to be stuck here, because if this is the case, because right now r would be sitting on a value greater than this and less than the min, or less than the min. So r is going to be sitting here, so we kind of want to just push that forward and then reset this pointer to here and here. So we kind of want to get it past this roadblock. But my main concern is this is not going to count the numbers right. Which it doesn't, like I thought. So we get a 4 and there's 2. Here we get 8 and 10. And here we get, okay, well, yeah, obviously that's not gonna slide. But we can obviously the runtime is way better, obviously because of it. Now, how did this get 4 is the question. So we go here, here, here. Here, and then here. If I add this and this decreases by 1. Well, no, this is just wrong because this didn't even work. So that's not even gonna help. That didn't even change anything. So how am I going to keep account for this? Well, maybe I can say ants plus equals L. Which that shouldn't work, but I just want to see what's going to happen. It's worse than before. Yeah, no. Okay. So how am I going to make this count correctly? It's the right idea, but how am I going to make this count correctly? Shit. Wait a minute. Wait a minute. Okay, so that's gonna double compute. Let's just have another if statement here. This is stupid, I know, but whatever. Just trying to see what's gonna happen. This is gonna give me an error. This case worked, but this case didn't, and this case is way wrong, but I have a feeling why. 7. What's 7 plus 3, guys? It's 8. No, wait, what? 7 plus 3 is not 8, it's 10. If you notice, this is counting all these. It's counting this, then it's gonna count this, so it's gonna count 1, 2, 3, 4, 5, 6, 7. But it's not counting these individual pieces right here. That's the problem. Now, how are we gonna fix that? I honestly don't know. I'll be straight up. I know what the problem is. It's not if it's the case of it being like individually right, like the subarray can just be a size 1, it's not gonna count it. I ran into this problem before, and the way I solved it was I did that for loop trick before, but obviously this doesn't work here because it's going to TLE. So maybe if I instead of saying answer plus equals 1, we can just add to answer, not what L is, because that's going to overshoot ourselves. Well, yeah, but if I add how much we changed by, that doesn't help. Because this is, if I add by L, this is going to be saying everything to the left of it's valid, which is not true. Which is effectively doing the same thing as if I had this answer plus here. So that does not help me at all. I don't know. I guess it's time for topics. A Q. Monotonic Q. We spent an hour on this problem. That's kind of crazy. And I haven't learned a lot. I've just been sitting here thinking, how would a monotonic Q fix this? fuck is the inclusion-exclusion principle? Oh, no, this is discrete math. Hell no. But I don't know that. Divide the array into multiple subarrays such that each number and each subarray is between k and x exclusives. Solve the previous problem for each subarray and sum all the answers. Divide each subarray between m, k, and m and k inclusive. It's like a really good, that's basically like the solution. But can I see it though is my question. Can I see that solution? Divide all the subarrays between these two values. Between. I don't know, guys. I guess my friend was right. Not gonna get it. Let's go to discussions. Okay, no duh. I know that. Yeah, that's what I was thinking, because like the Q is not gonna work. So he used pointers and made it O of N. So obviously pointers is the way to go. Fuck. See, that's not gonna help because I was thinking, okay, if I take that original for loop I had and like shrink it down, that doesn't work either. And the problem I'm running into here alright, maybe if I can cheat this. I'm gonna try to cheese it. If I can't get away with cheesing it, it's over. It is over. Let me restore myself to back where I was. Obviously that wrong and that's wrong. Okay. 2, 2, 2. So it's not gonna count the last one, but it does count everything before it. So what we're gonna do is for and num and nums. If nums is equal to, or okay, so this is all I'm gonna run. If min k is equal to max k, then for num and nums, if num is equal to min k, answer plus equals 1, or I would say I in range of nums plus or plus of n of 1 to 1. If nums at I is equal to min k. It's not valid syntax. Okay, buddy. Okay, I see. Whatever. Oh, wait, this is wrong. This if statement's wrong. Or this for loop's wrong. Oh my, bruh, just run the solution, please. Okay, it worked for that, but then it didn't work for this. Why? Oh yeah, okay, no, this is not gonna work. I tried cheesing it, but it's not gonna work. Let's go look at a solution. I don't want to spend any more time on this problem. We'll come back to it later. Alright, initialize answer to 0 with 2 pointers, max L and min L to -1. Traverse the given array, nums left to right. If the current number is not in the range of max K and max L, reset the pointers to -1 and set the start pointer to I plus 1. If the current element is equal to min K, update min K to I. If the current element is equal to max K, update max L to I. For each element, add the maximum of 0 and the minimum of MKL minus start plus 1 to answer. See, I was thinking of doing something similar to that. But my thing was, I was thinking something similar to that where we kept like, and I said it earlier, but my thing was I was too strict on the sliding window things, so it wasn't gonna like actually pass this. But I don't understand this math part though. I get this. So if nums at I is less than min K or nums at I is greater than min K. So less than min K or greater than max K. This is like an invalid case. So then he sets them, he restarts them, and then he makes that subarray starting +1, which makes sense. And then if this is the case, and then what you do is at the end of all these if statements is you check the answer. So the answer is equal to the maximum of 0 with the minimum of minus the start. I just don't understand this math. I get this part. This makes sense. I was thinking of something similar, but I don't get this formula. And if I feel like I get this formula, so I'm going to draw it out, this would be a very almost OP thing. We have this, whatever. So he's taking the minimum of these indexes. So he's basically taking the minimum. So if we were running this from right here, we would take this. Now, he's going to take that, and then, so which would be like 1, and then he's going to minus it by wherever we started, which here would be, the start would be here. So since the start is be 0, this would equal 0 plus 1, which is 1. Because that is one valid subarray. Now if I had, let's say, this, so here and here for this example, our start would be here, and then our min would be here, and our max would be here. Take the min of these indexes, you get 1 minus 0, plus 1, you get 2. And 2 works because you have this subarray, and then you have this subarray. And remember, you don't want to include these middle parts. So it's basically just like a math formula to, it's like the formula, like an actual math equation to calculate this part, which is very smart. The start idea. And so like, because my issue was I wasn't thinking of a start. I was thinking more of you expand the window from each side, keep adding it up, but that doesn't work here. Now, how does this work for the answer 1? So for 1, you have right here. Well, because at the end, take a minimum again, you add it up, which will add up that initial index. You go here, reset these basically. That's 2. So that's 1 plus, so that's 3 now, because that's going to include this, and then okay. That's a genius. What the hell? You know, I'm not a supporter of copying and pasting, but I'm gonna do it here. I did not deserve this, but I am. Which this does make sense. This is Java code. This is not cheating. This is totally cheating. I got the badge, but it doesn't feel good because I totally failed this problem. It does not feel good at all. But what are you gonna do about it? I do understand these solutions though. This makes sense. But I want to read more. To count the fixed bounds, we need to identify the subarrays where the minimum is equal to that, maximum is equal to okay. We can iterate through the array and keep track of the last occurrence of min and max. Then each index we can calculate the number of fixed bound subarrays ending at that index. Makes sense. They use the same formula. Alright, so I really need to understand when it comes to these types of problems, the idea of like having like a math solution to like calculating these subarrays. So a lot of these times when you need to do this O of n solution, a lot of these solutions will have something similar to that. Rip. That was sad, but whatever. We continue. It's been an hour on the daily. Was this a very productive hour? No, it was not. I'm going to be so straight up. I did not really learn anything. I just had an epiphany of, damn, I need to really understand how to do a little bit more math. But the next hour of this stream is going to be very productive because we are going to be doing some DP problems. And I'm going to grab these DP problems off the neat code list, but I will be right back 1 second. That was an L hour, but whatever. Hopefully we redeem ourselves. Let's do this problem. I've solved this problem before, but I want to solve it again. So, min cost climbing stairs. This is a DP problem. Now, why is it DP? Because of this. So I'm going to be doing, I'm pretty sure this is bottom-up DP that I'm about to do, because I'm going to be starting at the end. The reason why I know I'm going to be starting at the end, and the reason why I say this is because my intuition leads me to start at the end. This doesn't always work, but it does work a lot of the time. Because the goal is to reach the end of an array. Normally when you have to travel through a whole array and there's like cost involved or there's like trapped or whatever, you can't walk in a specific spot, I always find it easy to start at the goal and work your way backwards. So for this example, 1, 100, 1, 1, 1, 100, 1, 1, 100, 1. Our goal is to get here, right? Now, we can do two options. We can either start from here or here, right? Because if you end up here, you end up here, you're gonna reach the end, which this is the goal, right? We need to start from one of these two. What we're gonna wanna do is store the result in this DP array. So, if we start here, what's the minimum? The minimum is gonna be 1, right? If we start here, the minimum is going to be 100, right? Well, we don't want to do 100. Here are our two options. You can either have this or this, right? Now you can either go, because if you start here, you can either jump here or you can jump here. Now, at this starting point, if we landed here, your min is going to be 100. And we have this, right? So we're going to start working backwards. Now if we start here, we have two options. We can go either this way or we can go this way. Well, these are always set, right? Now if we look from here, we can kind of like, we can go backwards and we can look at this spot. Well, from this spot, we can either choose this or this, right? To get to our goal. Now we want to obviously choose the minimum of these, so it's going to be 1. Now we can start here and we can choose either this or this. But in reality, what this is asking us to choose here or here to get to the goal. But we're going to choose 1. Right? Now we're here. If we took this spot, we can either go here or here, which would be 1, right? But the thing is, it's not asking us like what's the absolute minimum along this path. It's asking us how much do we have to pay. So let's back up here for a second. Let's back up. DP is equal to this. Actually, now I'm thinking about it. Do I want to start there? And I think I do. Let's just run the bottom-up approach. So we can either start off with a 1 or 100. Now if I take this approach, I can either be at 101 or 2. So I'm going to take 2, right? So I can either go here or I can go here. We're going to take the min of this and add it plus itself. Now here, now that we're here, we can look at these two. We can either go here or we can either go here. Well, obviously we're going to pick the min and add it to itself, so that's going to be 3. Now we're here. So we're going to look here, and then we're going to look here. If we take this approach, we're obviously going to pick 2 because that's the minimum. So we're going to add it up, which is 102. Now if we start from here, we can either pick 102 or 3. So we're obviously going to pick 3 because that's the lowest. And we can just kind of repeat this pattern. See, we're going to pick 4, that's 5. And then once we hit here, we're going to pick 4 and add it to itself, so this is 5, right? Because we can either pick from here or here, so we're going to pick 4, right? That's 5. 100, we can pick here, here, that's 105 no matter what, and then from here you can pick the minimum of 105 and 5, which is 6. And then you return the last one you want. So, how do we code that? Well, dp is equal to 0.99 times, or actually let me get the length of cost. Now, we're going to return dp at n. That's one. Oh, we're just going to return the last. We're actually going to return the min of. It doesn't matter because we can either start here or we can start here. We're going to return the min of dp minus 1 and dp of n minus 2, right? Because we can either start from these two positions, right? Now from here, we can start working backwards in the dp. We're going to start from n minus 1, work our way to, or just work our way down. Now, what we're going to say is, the first two, right, the first, like, 2 dp is always going to be the last two elements at the start of this, right? That's, again, not what we're calculating. So we have 101. So we can actually start at minus 2 because we want to start 2 back. Pretty sure, right? What do you think? How do I want to structure this? No, we want to start at minus 1. Oh, but the problem is this DP is going to be working. This loop is not playing in my favor. Here, let's not worry about the return yet. That's the idea behind it, but let's not worry about that. But we're going to be starting backwards. I'm thinking I just go in this DP and I select the, and I kind of just hard set these values. Because this is confusing the fuck out of me. For no reason. DP at 0 is equal to cost at this, and then DP at 1 is equal to cost at this. Let's just see if this even compiles. No, compiles, runs, not compiles, Python, but whatever. Pretty good. So let's go through here, and now that we have that, we can actually now go and run this. This is probably not the best way to do this. It's definitely not the best way to do this. But whatever. This is not the best way to do this DP, bruh. I'm gonna be so honest. This is ass. This is ass code. Trash code. Oh, hell nah. This is so bad. Wait, nah. No. Okay. DP at I is plus equal to the min of DP, or is DP at I is equal to cost at I plus equals the min of DP at I plus 1 in the DP I plus 2. Now run this back and then return the min of DP at 0 and the DP at 1. Okay, that's crazy. Oh. Damn, that's crazy. Okay, I guess I'm trash. Oh, -3. Yeah. Submit. Nice. Alright, is there a cleaner way to say this? Let me see my past solution. Submission. Okay, I did this a couple times. I trust this answer more though. Oh yeah, I forgot that I can do that. I forgot that you can do it like that. That's clean. That's clean. How did I forget? I remember coming up with this, and I was mind blown that I figured that out. And then I just forgot it and did the trash solution. Damn. And I didn't go backwards in this one, so I went forwards in this one, which is honestly fair, because going forwards makes more sense too. Now that I think back at it, yeah, going forwards would have been a lot smarter than this. I've definitely lost my DP skills, bro. All right, so the leak code contest is in 10 minutes. Wait, what time is the leak code contest? Is not in 10 minutes. Boy, I just lied to me. When is this leak code contest? Okay. No, I'll register in a second. Not on stream though. When is this? It starts in 42 minutes. That ass. We got. Bro, you were right. Honestly, bro, you were right. I didn't solve the daily. I got close, bruh. I got close. I just didn't know how to calculate. I just didn't know how to calculate, like, the formula to calculate all the sub raised to the left. Like, for the life of me, I could not figure that out. But I had the idea. I knew what I was doing besides that part. That's what I need to get better at when I do sliding window. Oh, wait. Don't look at my solution. The hell? But, like, it was so unfortunate, because... whatever. I'll get better at figuring that stuff out. But today, I'm trying to practice a shit ton of DP. I want to get my DP game up. So I'm just doing leak code DPs to practice. Alright, let's do coin exchange. You know, this might be a harder problem, but let's do it. Isn't CSDP harder than some leak code DPs though? Because I want to, like, I suck ass at DP, so I don't want to jump straight into CSDP or even code first to DP. Nah, somewhere good. Alright, I'll try them. I want to become a DP. In the next couple months, I want to become the DP GOAT. That's the goal. Any problem can be solved by DP. Actually, that's not true, but I don't think it's true. Honestly, I see the backtracking solution, but backtracking isn't necessarily DP. Backtracking isn't DP, right? It's backtracking. There's a difference. Because I can backtrack this, but I want to DP it. So, I mean, how would I run this? Backtracking solution is we also really want to use the fewest coins as possible, so we obviously want to do a greedy solution. I think I'll full send the greedy, hopefully. Actually, I don't know, that's a good idea, but we'll try. Is there any way? I see the backtrack, but I don't see the DP. Thanks, bro. Thanks, bro. I'll be here. I'll be here. Grinding away. It's the same problem. I'll be here live streaming every time I can. I've been pretty busy lately, but it's the same problem. It's bad tracking DP. Some. Oh. Oh yeah, it's the same. Wait, how did I solve Fibonacci DP? Because I remember I did that. I should have probably done that first, now that I think about it. Whatever. So I see that I can either, I have these lists, right? I can choose from any of this, a starting point. So if I start at 5, wait, let me go to Fibonacci and let me see how I solved the Fibonacci problem. Because I remember I did that. Fibonacci number. Let me solve this DP and then let me go over to this problem again. I think that's a good way to get ready for coin exchange. Oh, that's the solution. What the hell? Why is it just sitting there? I did not look at it, just so you know. I didn't do any contests yesterday. The last contest I did get smoked though, I'm not gonna lie. I'll tell you that much. But I'm gonna do the leak code contest coming up in like 30 minutes. But I can't live stream it, but I'll record it. Alright, so the DP is equal to this. So while your Fibonacci works like this, right? So it's actually going to be 0 and 1, right? So while n is greater than 2, n minus equals 1, and then we're going to say dp is equal to, and then you want your current, which is going to be equal to 0. So cur mod 2. So the dp at cur mod 2 is equal to, actually this needs to be while n, well, while cur is less than, well, cur is going to be equal to 2, and then while cur is less than n, this is going to be equal to, let me actually think about what I'm doing here. Because Fibonacci works like this. You have a 0 and then you start with that, right? So you start with this. And then from there, if you're at 2, you basically take the sum of this. And then you kind of like insert it right here. So you take the sum of this and you insert it to whatever like you're at. So I could just say the dp at cur mod 2 is equal to the sum of dp. Or just dp, just say sum of dp, right? So you add up the current, do that. You don't really want to say that anymore, but you want to say that. And then return I think. If this doesn't work, I'm actually gonna sit down and write it out. I don't really remember. No, that did not work. Maybe the max of this, because the Fibonacci number, the max would be technically the last. Okay, no, this is actually trash. This is trash code. I need to actually write this out. Damn, my DP skills have fallen off. That's crazy. My DP skills have fallen off. So here we start with here, and this is your starting point. Now, the Fibonacci number for 2 is equal to f of 1 plus f of 0. Right, which is just equal to 0 plus 1. Which is basically saying this position plus that position is going to be equal to that. And then like you rewrite this, so this will be 1. So what you're gonna have is, after this iteration, dp is gonna be equal to 1 and 1. Because this is storing f of 3, and this has f of 1 here still. Or wait, no, this is f of 2, my bad. Right? Then from there, you can kind of just like flip these around. So now if we're going to calculate 3, it's going to be basically 1 plus 1, which is 2. And then you're going to go here and you're going to set this, because this stores f of 2 and this stores f of 3. And then again, just keep repeating. So, how do we want to say that? So we initially start with our DP. Let me rewrite this. We don't really want to return them. So, while I guess cur is less than n minus 2. So your 3, you only want to run it one time. Well, you actually, if you have, it's 1 minus 1, right? Because 2, you only want to run it one time. So, what you're going to say is, again, cur plus equals 1, dp. So, this mod is going to keep it like in check. So whatever at, if it's like an odd, because all the odds are going to go right here, and all the evens are going to go right here, right? So whatever we're at is going to be equal to the sum of dp. Obviously increment that. And if I actually say this, I can return the sum of dp. And wait, before I run this, I need to explain why I think this is going to work before I actually run this, because I don't want to just full send this. We have this starting position, which is f of 0 and f of 1, right? We want to run this while this is the case, but we basically keep this current variable, which is like whatever one we're calculating. So right now, ooh, we actually want to be calculating a, because this is going to override to a 0th position, which is what we want, because we're going to calculate f of 2 at the start. So this is going to be, at the first iteration, this is going to be f of 2. F of 2 is just whatever's inside this. And you write it in there, and then you go here. So now we're going to be at f of 3. The reason why I say minus 2, though, is because the Fibonacci of the last number is just basically going to be this. And to like prevent like us having to decrement C again, because if I said this, we would have to find like whatever the thingy was, and then, yeah, whatever. Hopefully this works. I think this should work. And it does. Yeah, that seems good. Minus 2 because we don't want to account for the last 2, because the first 2 Fibonacci numbers are already calculated for you. And then again, we say minus 2, and then normally that would be minus 1 technically, but minus 2 because if you would run the calculation of the final Fibonacci that you wanted, but then your plus C is going to be off by like 1. And it's just better if you just, and it's easier if you can just say sum of DP instead of dealing with all of that. So yeah, let's submit it. Let's see if it works. It should work. And there we go. So let's look at my past missions and let's see this. Obviously that was wrong. Wait, what is this? Oh, that was a one-line try. Okay, so I stored it in a temp variable in the past. Yeah, I don't really. That's kind of dumb. What I do here? Here I just did the DFS way. Okay, I don't feel too confident going into coin exchange now, but that was a good little problem. If anyone has any easier DP problems I should try out first, feel free to leave in the chat. But here, how do we want to start off at? I wonder if I should go in and do the DFS solution real quick, and then come back and do the DP solution. Let me actually draw out like the DFS way of doing this. The DFS way is you have like a target. You have your target. Ugh, that's ugly T. You have your target, and then you have your current, right? Which is 0, and this is whatever your target was, right? And then from here, you can like kind of have a tree. And then from this tree, you can either choose, well, you're gonna start from this, you're gonna loop through all this and pick every single starting point to try it out. But from here, you can either choose to add yourself. DP is a DFS. Okay, so you either choose to add yourself, or you can either choose to increment I, which then would like move I, or decrement I, or whatever you want to do. It doesn't really matter. Actually, decrement I, because you want to start at the greatest and work backwards. And yeah, and that's how this tree would kind of work. You either add your current, decrement I, and then you stop doing it if your current exceeds T, or if you hit T, you want to kind of stop doing it, and you just keep the min of whatever happened. So I could see a solution where I guess we could just do this. If I do this, am I cringe, or is there like a better way? Or should I just do it this way? Because I'm thinking I have an array basically of the min, which is for each array. I don't know. I don't see a way to DP it unless you do a DFS. Should I just full send a DFS? Is that the solution? There's no way to do it like how I did Fibonacci number or anything? Like where I had this like DP array? That's my question. Can I do it? Do the DFS? Well, fine. Fine. So we're gonna have a current, we're gonna have I, we're gonna have a current, and we're gonna have a target. Actually, we don't need to pass in the target. Here, we're gonna say if target's greater than, let me say this could be T, and this is going to be sure coins, I don't care. So if C is greater than T, return alright, so if C is greater than this, return or I is less than 0. So if this is the case, return. Else, what you want to say is you want to run a DFS where we add coins at I, and then you want to run a DFS where you don't do that. So you can either choose to add I, or you can choose to not do that and decrement I. So you can add a coin, or you can just decrement and not add it, and then you pass in your current. And then if C is equal to T, return, I could either return the count. Oh, I also am going to need an iteration count. So it is going to be, and then pass in the it and pass in the it. And then we're going to return the it count. So here we're going to return, and then here we'll return infinity. And then here we'll return the min of these two. So we want the minimum it count of this. This is kind of a cringe DFS, I'm not gonna lie, but we are gonna roll with it for now. So let's just print the DFS, or so for I in range of length of coins, DFS I 0 0, and then just print this. That's what happens. Index out of range. If I is less than 0, break. How can I be out of range? What? How is I out of range? List index out of range. I guess I'll have a or I greater than length of coins. Okay, this is not good. I don't understand why I would be. Well, I need to solve this problem quick because the contest is coming up. But I don't understand why I would be going out of bounds if I set this. Oh, because I said this. That's why. Okay, no, this is not working. This is not working. This is not working at all. Why the fuck is I going out of range? For I in range of this DFS, okay. Print I. Not being stupid, am I? 0, 1, 2. Okay, 0, 1, 2. Now, if I is less than 0. Well, if it's less than 0 or I guess is greater than length of coins. Let me actually have an n variable. I mean, it doesn't really matter because coins is only 12, but I like doing this. And so if this or that, make sure this is equal, or the current, well, if this or that, return 1E99. Whoa. If C is equal to target, return the it count. Else what you want to do is you want to say it plus equals 1 because we're running another iteration. And then what you want to do is you want to say we can now run return the minimum of a DFS of if we say, oh, I know why that was going out of bounds. Oh, I'm stupid. Of I, where we add itself. So C plus the coins, and then it. Or we can say DFS at I plus 1 or minus 1, and then C and then it. That's why I was going out of bounds. Oof, not looking good. Or current is greater than target. So we got an 11, we got a 7, and we got a 5. That is not what we wanted. So this tree is kind of not working here. Well, why is this tree not working? Well, if I had this number and I started here, I could either go here. So let's just say I had this. We start at 0, or whatever. So if I go here, I can add. So we have 5, and then what's going to happen is we're still sitting here. If I go here, we can go and we can add 2. So now this is the case. Now in this tree, I can go and I can add 5 again. So I get 10. And then I'm here. Now in this tree, I can go and I can say, okay, well, move this here. And we're still at 5. In this tree, I can say, okay, here we're going to hit 15, so we're going to break out. Right? Here I can say, okay, keep 10, but move I to here. And then in this tree, if I add here, we're going to go over, right? But I is still going to be sitting here, but since this goes over, we're going to break. Now if I go here, and go down here, and I can say, okay, well, let's... Oh, okay, I only want to add to the it count if we add ourselves. Three, infinity, 0. All right. 1, 2, 3, 4, 5, 6 for the number 100. Oh, I don't even... That makes sense, because you only are using a turn if you add to that. Yeah, okay, yeah. And then now we can just say, I guess we can just say the min is equal to infinity. Min is equal to min and DFS of I, 0, 0. If return 0 if min is equal to I99, else return the min. You want to return -1 actually. Okay, that's really slow, but we're gonna full send. If I get a TLE on this, that's gonna be very embarrassing. Oh shit. It's not looking good. Damn. Okay, so this didn't work. Damn. Alright, let's try that. Let's prune that off. Does that increase my runtime? No, it didn't. I thought it would. Because what I'm doing is I'm going backwards now, right? I'm going to say, okay, here I can just be like, because what I was saying is like, okay, well, if we equal the, if our it count is greater than or equal to our min, let's break out, because that means there's no chance of us hitting it. And also, if we're already at the min, then it's not going to work. This is not going to work. Damn, okay, so the DFS didn't work. Is it because I'm stupid or what? Whoa. That's interesting. So this is not as simple as I thought it was going to be. I thought this was going to be simple and I could just full send a DFS. Like a dumbass DFS, like a dumb DFS too. But it's obviously not. Okay. I have no idea how I should DP this, to be honest. Look at the tags. Dynamic programming. Breadth for search. I mean, whatever, they stupid ass tags like that. A breadth for search. I don't even know. Alright, I'm gonna look at the discussion. Why not greedy? Makes sense. DP's hard. Don't get discouraged if the solution doesn't come up easily. Practice makes perfect. Thanks, bruh. Thanks. Yeah, because obviously I'm struggling, bruh. Whoa, 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 whoa. Take coins 1, 2, 3, 5 and an amount 11 as an example. If I use 1, I know I know that the fewest coins I could possibly make up is 10. EX 10, DP 10. Overall, I would need 1 plus DP 10 coins. If I use 2, I need 1 plus DP 9 coins, and if I use 5, I need 1 plus DP 6 coins. Whoa, what? Therefore, I need to calculate DP from 1 to amount. Whoa, what do you mean, whoa? Whoa, what do you mean, whoa? Just, bro, I can't optimize it anymore, bro. I already tried, bro. I can't do it. I suck. It's over. I'm just reading discussions, bro. Trying to get a hint. No solution. I already have it. How many were, like, whatever. The current minimum. I start from the greatest. Oh, yeah, true. I forgot that existed. I forgot about that. But, I forgot how to do I forgot how to, do that. Yeah, so, I already forgot. I forgot how to do that. But I forgot about memorization. That's actually kind of important. I is the index we're at, because I was doing, like, DFS. Ah, fuck, I forgot about memorization. Shit. Okay, I think for this, the fuck? Just iterate through the coins in the DFS function. Yo! Wait! You're an actual genius. Oh shit. So get rid of I. There. Is that clean? Or should I just, and then should I call the wait, should I just call the DFS, and then instead of doing this, should I just say DFS it keeps track of like how many like layers, like kind of like the level that we're at, and like how many times have we used like a coin. This doesn't exist anymore. What? Dude, do you know the problem? Because you need to keep track of the current level you're at, bro. A return type. Okay, so how am I supposed to keep track of the level if I can never increment the level? Like how am I gonna know how deep I am into the DFS? I don't believe you, bruh. I'm not believing you. I'm not believing you. I'm not believing you. Yeah, you don't even know what you're talking about, bruh. Oh shit, I can't reference min in here. Ooh, no. Wait. I got it. Yeah, that's making a lot of sense. It's making a lot of sense. Nah. What am I memorizing? The it? No. I can't. I don't even know what I'm doing, bro. I'm gonna be so straight up. I don't know what I'm doing. I'm lost, bro. I'm gonna have to come back to this. I'm gonna have to go learn. I'm gonna have to go relearn memorization. Okay, wait. I need to stop. I need to get ready for the con. Alright, let me restart real quick. I have 8 minutes to the contest, or whatever, 6 minutes. What I want to do is I want to run through every level. Okay. So n, go to length of coins. Now, find a DFS. Now inside this DFS, we're going to keep track of the current. Straight off the start. And then, if current is greater than our target, return. What do we want to return if it's greater than? Because it's that's invalid. Since it's invalid, let's just return like infinity or something. Now, for I in range of n, call this DFS on the current plus coins at I. Now, we're gonna have a min, and then if C is equal to T, return 1. Now, we need a self.min. And then we want to say self.min is equal to the minimum of, this needs to be infinity. And we need to say the self is equal to that plus 1, because since this is a recursive call, when we hit the target, that means we're at the bottom. And then since like a stack, we're just gonna pop back up, and that's why that plus 1 is there, because it's gonna recalculate the level. Because it's gonna go all the way down, which then it hits 1, and then it's gonna go up. And as we go up the chain, it's gonna be adding 1 to each like level, which is gonna give us this. And then, yeah. Now, if we run this, this shouldn't work. I don't know if this will work fully. I don't have to say self up here. Bro, you're making excuses, bro. You're making excuses. -1, so that's not good. That's not good. Oh, because I never called the DFS. That would help if I called the DFS. I'm just gonna say DFS of 0. This is not callable. Oops. Are you saying, are you calling me out for not returning the DFS? Or are you saying I should call the DFS because, oh my god. Because what I'm saying is, oh wait, here, I need it. Because I don't want to return anything. I have this like global min. Oh, stop. +1. Quick. Contest is in 2 minutes. What? Define. Oh, Wait, I have it, buddy. Yo, stop. Yo, chill, bruh. Chill typing out everything. What's wrong with you? Wait, why is this wrong? Why is this DFS not working? Plus? What do you mean plus? I don't know, return 0. N plus equals 1. Alright, it's over. I'll solve this next stream. I gotta go, boys. I gotta go do the contest. I'll keep you updated. I'll never be a DP. I won't be. DP champ didn't come to this stream. I only saw one DP problem. But DP champ will come next stream. Alright. I gotta go. Contest.